When you ask people what edge compute is, you get a range of answers. Cloud compute and DevOps with devices and sensors, with semiconductors outside the data center, including connectivity, AI, and a security strategy. It's a stew of technologies that's powering our vehicles, our buildings, our factories, and more. It's also filled with fascinating people that are passionate about their tech, their story, and their world. I'm your host, Pete Bernard, and the Excelsior Show makes sense of what edge compute is, who's doing it, and how it can transform your business and you. So let's get started. So do you use a Windows on Snapdragon PC at work? Or is it Intel? Or is that a secret? That's right. You don't have to answer that. I'm a huge fan of Windows on Snapdragon. That was one of my projects at Microsoft. So,
I'm a huge fan too. I'm a pretty proponent on Windows on Snapdragon, and that's what I'm marching towards with my next goal here. Yes.
Awesome. Yes. No, I was mentioning before we hit the button about the Snapdragon Summit, and you and I have something in common. We're not there, but I've been there a few times, and such a fantastic event. I saw a video with Don McGuire talking about going back to Maui and the decision to go back to Maui, which is a fantastic, first of all, fantastic decision, but also a great way to tell that story. Yep. So anyway, I'm seeing the posts on LinkedIn from my analyst colleagues who are all sitting there in Maui, and I'm like, okay.
It's going to be a very, very exciting week for sure. I mean, I'm looking forward to, I know all the announcements. I'm just looking forward to all of them just coming out now. And it is certainly going to bring a big splash, especially in the field of AI.
Yeah. Well, let's kind of get into it. First of all, I have a really bad habit of just sort of getting into a conversation with someone without introducing them. So before we go any farther, let me introduce you Megha Daga from Qualcomm. And I really appreciate the time. And I've been told that you are really the AI expert there, especially in the areas of IoT and some of the edge compute stuff that's going on. So I really appreciate making the time to talk with me today.
Oh, thank you, Pete.
You've been at Qualcomm a few years. I saw on your LinkedIn profile you were at NVIDIA, Cadence. I mean, you've been digging into this AI and silicon kind of combo for a number of years. I mean, what was it that kind of drew you to Qualcomm, maybe other than San Diego, or what was the draw?
Yeah, so like you mentioned, I mean, I've jumped a few courses for sure. Started in a startup company as a hardcore audio engineer, worked on cochlear implants, did home theater systems, and so on. Went to NVIDIA, again, started in audio design, but I have tried to see, I mean, at the end of the day, it's all about math, and from audio moved to vision.
Right.
And started looking into traditional computer vision, which got me more and more intrigued as you start looking at these data in different formats and how you can play around with that data. And then from there, moved to Cadence Tensilica Group. And there also I was working at our computer vision IPs. That's where I'd marched into the darker side of the things, into product management. And looked into the evolution of computer vision and what it can bring into our industry, in our daily lifestyle that we are dealing with. And soon, and at the same time, the whole evolution of AI was happening. And it's very intriguing, that whole field of how it is taking on one of the fastest moving technologies today. And soon marched on from that traditional computer vision into creating specialized IP cores for AI acceleration only. So that's where I marched into the land of AI and starting Tensilica, doing on the IP. And then when I was looking at the next step, it was certainly from IP going into a chipset, right? And how we can create a whole stack onto those chipsets. And that's where the Qualcomm opportunity had come in, where, again, it was very interesting because it was overlooking an entire spectrum of IoT, which is one of the most fragmented fields that we see of today. Right? Looking at the small doorbell or a edge gateway in your home
Right.
to all the
Right.
way into an industrial scenarios. We're looking at industrial PCs to AMRs to humanoids. It's just a vast variety to play around with, and especially with AI, which is emerging across the field. So it was very
Right.
interesting, and hence the move. So yeah, that's how the Qualcomm
Cool.
journey has started. And yes,
I
you are
see.
right,
Yeah.
not been too long.
I studied a lot of audio engineering at school, like DSPs, and that was kind of my first. I was a real, and still an audio kind of nut. You can tell I've got the cool microphone and headphones and stuff. I'm still an audio nut, and I kind of fancied myself as a digital audio engineer at one point. And you're right; it's about the math, and the math is just getting more evolved, and the semiconductors are getting so much more powerful to drive so much more math that you can just do things that were just not even possible,
Exactly.
5, 10 years ago. And so anyway, so let's talk about that. So you've been at Qualcomm for a while. You're focusing in kind of on the IoT space, which, a lot of people think of IoT as kind of low power sensors, but also it can be very heavy industrial stuff too, right?
Yep.
And so where are you seeing AI sort of being the most transformative right now in sort of the IoT and edge space?
So the biggest place where we saw a very quick transformation was directly
Hmm.
in the hands of consumer, right?
Hmm.
Especially for IoT, and this is where we start talking about in the consumer space like a retail scenario, and the COVID timeframes did the biggest evolution for that as well, where everything has
Right,
to
right.
be touchless scenarios, all restrictive domains, access control, all these
Hmm.
things kicked in, and everything was AI driven. And
Right,
that
right.
was something that became like a day to day thing for us. So, that
Hmm.
whole realm of activities is somewhere we see a lot of AI coming in and playing. uh, it's the growth on the lower end of the series is much more slow. Again, it's the evolution. So I see it as a trickling down nature of what we would see.
Hmm.
The other area where things are always slow is in the matter of industrial, right? So it has taken quite a time for industrial market to come to that, but this is the time where I think they have marched to that path where all the heavy players into the industrial automation are now there to start talking about AI and how it's transforming different type of activities, be it from a worker safety environment to a manufacturing belt line to a whole
Hmm.
operational efficiency side of things. So
Hmm.
certainly started with the consumer, and it has gone into the backweeds up to the enterprise as well.
Yeah, no, it's interesting. You mentioned retail. I mean, that's a really interesting intersection between commercial and consumer,
Yeah.
since we experience that on a daily basis. Going into the store, self checkout, security, food freshness, product counting, inventory control. I mean, there's
The
like,
list goes on.
probably a
Yes.
100 pages worth of scenarios just in retail for AI and stuff. And it's something that we, as consumers, it's something we can relate with. I think the other one that I've heard too a lot is around healthcare. Certainly AI and, in terms, image analysis and things like that. It's
Mhm.
pretty well documented. I think the whole sort of, you know, uh, robot surgery thing is probably not something I'd be too keen on, but I think the ability to use AI to make better decisions and bring more knowledge into the healthcare environment is certainly something we can all relate to as well. So I mean, Qualcomm is as most people know, been around quite some time. I just saw that Irwin Jacobs had like his 90th birthday,
Yeah.
the father of CDMA.
Yeah.
And so Qualcomm's been around a long time and actually has been a pioneer in a lot of this kind of low power edge compute and had AI acceleration in Qualcomm silicon for quite some time, especially in the AI vision space.
Yes.
And so tell me a little bit more about sort of the transition that you've seen over the past 5 years where, yeah, it's been like, it's been on the Snapdragon chips for phones.
Yeah.
There's been a pretty healthy business, I'm sure, around AI vision and cameras for Qualcomm. And so how has that evolved into some of the other sort of AI scenarios that you're you're seeing today? What's sort of the new ground that's being broken here?
Yeah. So, I mean, like you very well said, Pete, right? I mean, Qualcomm has been there for more than 15 years now in this field of AI and catering to
Mm-hmm.
the evolution of the AI. I mean, the evolution of AI itself, which started from AI going into machine learning, going into deep learning, and then into the generative AI. I mean, all these evolutions are happening. There has to be, first of all, a hardware to cater to those evolutions. And
Right.
if the evolution is happening, that means there is a need somewhere. That's why the evolution is happening, right? And as the need is coming, more and more requirement is coming, more and more
Mm.
people are getting aware of those requirements, both from a consumer and from an OEM aspect of things. They want to do
Mm-hmm.
more at the edge. And Qualcomm, obviously being the pioneer in the area of mobile, we were the first ones to bring these capabilities in hands of a consumer, right? Starting with face recognition kind of an app or a voice recognition kind of an app, which are all underneath AI driven, is something that we started with. So for IoT space, the way we see we can very well leverage all that was done on the mobile onto the
Mm-hmm.
IoT realms now, because all that beauty just helps us more and more. We are those devices which needs that high energy efficiency criteria. We are those devices where we are seeing a significant growth in the use cases with respect to smart enablement. So
Mm-hmm.
we are able to leverage the hardware that we have been growing as Qualcomm to cater to
Mm-hmm.
the AI needs. And in the last 5 years itself, or 5 to 7 years, if I think about it, where we used to have chipsets which were just typical CPU, GPU driven, and
Right.
getting AI applications or machine learning applications like SVM and so on getting deployed on those. We then clearly added a CDSP, DSP, which was catered towards AI applications or
Mm.
deep learning applications. The intrinsics which go into that DSP over generations have become more and more efficient to cater to CNNs and then RNNs that came as part of the deep learning. And then we suddenly realize, okay, more use cases coming to edge. So more compute is needed of the edge, but we can't make the edge heavy. So we need to keep our footprint small, all from the power and cost perspective, and still
Mm-hmm.
cater to those new requirements. And for that, we added accelerators catered to the AI. And again, with our learning and all the use cases that we are fed into the company as Qualcomm, we were able to get into the newer and newer architectures of that accelerator tightly coupled with the DSP and maximizing the memory management footprint inside the architecture so that we can get the max efficiency out of
Mm.
our architectures, right? In this
Right.
industry, many times people, when they ask, hey, what is your AI capability? They are just looking for the mere number of tops,
Right.
which is such a misnomer, right? That tops doesn't mean much at the end of the day because I can get more performance out of the same number of tops between the two chipsets. So it's all
Mm-hmm.
about the efficiency, how those architectures underneath are designed, and how very well you can utilize those architectures which are designed. And which is
Right.
what
Right.
Qualcomm has been doing and has done over the period of years,
Yeah.
right? And we have been proving that
So
on and on.
yeah. So just to radically oversimplify for our listeners, so there's the usually you start with some sort of AI model. You train the model on a bunch of data,
Mhm.
a bunch of clean labeled data. You train the model, and then you deploy the model, and you run the model. You run inferencing based on the model, and so typically, Qualcomm silicon is used to run the inferencing, running the model and the inferencing, but the training is still done in the cloud. Is that still
That is
the
still a
domain
valid
of?
statement.
Yeah.
Yes. Yeah.
Hmm. Okay. And so, and do you see that changing anytime soon? I mean, are we looking at edge-based training in
For
the next
sure.
X number of years, or?
Oh, that is already happening for sure. I mean, even
Hmm.
like if we think about, let's say, a scanning application on a belt,
Hmm.
right? And if we go from a square nut to a round nut, we don't want to go back and retrain the whole thing. So we can
Right.
have that capability of retraining at the edge to just tweak the last few layers to understand that I have gone from square to a round. So
Oh,
that
okay.
kind of retraining capabilities, yes, are certainly needed at the edge so that you can avoid that bandwidth and the traffic that needs to happen back and forth from the
Right,
edge
right.
to the
Okay.
cloud.
So you can sort of tune the model. You can tune the model based on
Yes,
some edge data and still
yes.
and get some efficiencies there. That makes perfect sense.
Yep.
Yeah, no, it's for other just another education point for listeners. There's lots of different types of AI. I think some folks they think of AI these days, the past, I don't know, 6 months to a year, generative AI has been very hot, which is, generating cat poems and other
Yes.
kind of cool images and things like that. But as we were talking about, there's AI everywhere in retail and healthcare and industrial. And Qualcomm's been a big part of that. But tell me a little bit more about generative AI, because I think most people don't think of Qualcomm with generative AI or large language models. But in fact, I've seen some pretty interesting demonstrations of running LLMs on Qualcomm silicon, so you can actually do it. So can you talk about that a little bit?
Yes. No, again, I mean, proud to be a Qualcommer in that place, right? Where we are, again, one of the first ones who ended up showing these generative AI models running at the edge. So we were able to demonstrate stable diffusion or
Hmm.
ConvNet and those applications running smoothly. And you would be seeing more in the upcoming days. But what does that really mean, right? I mean,
Yeah.
running a model at the end of the day is just running a model. What we need is applications and the use cases. So let me put that in context of the use cases, what generative
Right.
AI will bring for us. We recently made an announcement as well, some of the folks must have seen, of Zebra and Qualcomm collaboration. And that's where
Mm-hmm.
we see
Mm-hmm.
that,
Some
oh,
of that.
okay, there is the, they're talking about now worker assistance program or consumer assistance program, where
Mm-hmm.
in a workplace environment, there are these handhelds or there are these kiosks, these devices powered by Qualcomm technology. You can use generative AI to quickly get answers to some of the things where these workers would have to probably go through huge manuals or a training in the back end. Now they can be, trained impromptu. So
Mm-hmm.
if they are, in a store, a consumer comes in and asks for a certain specific product in the store, they don't need to be trained for all the latest and the updates as of that very day. All they need to do is ask the device and get the data or the recommendation promptly, but
Right.
there and
Right.
then. And then,
Hmm.
I mean, again, why at the edge, right? That is also another thing.
Sure.
Why should
Because those devices are connected usually over some kind of Wi-Fi network back to some
Yes.
cloud thing. So.
So, yes, connectivity could be there. At the same time, I think there is a lot of data that we are talking about over here, right? And many times in the enterprise environment, the privacy of this data is very critical. So,
Hmm.
what data they want to send out of their premise becomes a critical aspect for them. So that's one nuance of things. The second nuance is always the cost as well, right?
Mm-hmm.
How much data do you want to send? The processing of that data onto the cloud, especially when it comes to generative AI kind of hot
True. True.
applications, those things
Right.
also start accounting for things. And lastly, latency, right? Some of these applications, not necessarily the one I just talked about, but let's say taking it to a manufacturing line, right? And there, if I'm doing a worker assistance program on a built line automation, latencies and things start becoming critical in certain use cases. And that's again where you want to be on premise, closer to your sensors, where the action is going to happen.
Right.
So
Right.
you do
Yeah.
see all
No, I
those
can see
things.
that. By the way, the killer app for me on you mentioned about going into retail stores. I use the apps now for like Home Depot and Safeway, mostly so I can avoid talking to the employees there. Now I can use it to find what I'm looking for and all the
Exactly.
information about it. So, so I think that's an interesting byproduct of these apps getting better is that you don't have to engage with what turns out to be fewer employees. Unfortunately, in some of those
That's another
places.
big challenge, right? Just to find a helper.
Yeah,
And
exactly.
that's where
That's
the
that's
consumer assistants come into the play. These
Yeah.
things.
So have you quantified like the cost savings? Because I think it's a really compelling value proposition to say, well, it costs less to do this stuff on the edge. Um, I mean, do you have some examples of cost savings, or is it there's the egress into the cloud? There's obviously your, paying your hyperscaler and all that other stuff that you don't have to do if you're doing it on device. But how does that pencil out?
Yeah, so not necessarily, Pete. I can share a number that these are the X factors that you are saving from going
Hmm.
there. But as you rightly quoted, there are costs associated with the transfer of the data. There is a cost
Yeah.
associated with the processing of the data. Most of these Gen AI models today get cost by either tokens per second or there are different mechanisms on the calls per second, the APIs per second, and so
Hmm.
on and so forth. So there is some cost associated with those as well. And it really depends on how often and what is the periodicity of these things
Hmm.
getting
Hmm.
utilized and used. So all
Yeah.
those will account for some or the other, which will vary use case to use case.
Interesting. Yeah, there's this notion, and I did a post on this recently around this thing called, I call it the energy dividend of the edge. And the idea is intuitively, I mean, I think you have the same intuition here, is that as you move more data to the edge, you're saving on, resources. You're saving on resources to run all those fantastic NVIDIA H100s sitting in the hyperscaler 50 miles away. You're saving on the networking costs. You're saving on all kinds of things, and the power, and even water to cool the data centers is being saved. So there's this notion of an energy dividend. The GSMA just published some data that it was interesting data. I wouldn't say it was, I'd like to double click on it, but showing that as you move data to the edge, the energy consumed, is reduced pretty dramatically. I mean, one of the interesting things also for our listeners to note is that when you have a data center, data center power is in the typically megawatts,
Mm-hmm.
many megawatts.
Mm-hmm.
Uh, and when you're talking about a Qualcomm chip that's in the sub 5 nanometer process is milliwatts. So we're on the whole other end of the spectrum here, which is kind of fascinating. So I'm just curious about this energy dividend concept, or how does Qualcomm think about conservation of energy and resources and moving more data to the edge? What does that sound like?
It's certainly, I mean, the whole aspect of, as you put, energy dividend, we also see it as a net zero goals for us. I mean, at
Hmm.
the end of the day, these are very important, critical things that we need to look at from a community perspective as well. Right.
Right.
And as we started our conversation, I mean, there's more and more use cases coming on, and we need to create hardware to cater to those use cases. So these data streams and for example, the number of camera streams that you want to process now versus what
Hmm.
they were before, right? They
Hmm.
have tremendously grown. So you want all those data streams to come in and get processed onto the edge. So you want to have that
Yeah.
capability from a hardware perspective to cater to that data stream requirements and keep it onto the edge
Sure.
so that you minimize that back into the cloud and then processing towards the cloud.
Hmm.
At the same time, you cannot afford to increase your power footprint, right? And because that will also move into the opposite direction of what we are trying to do with respect to energy conservation. And that's where, as you
Right.
said, from Qualcomm, I mean, we are again, one of those providers where we can get to the best of the technologies out there from the construction of these chipsets and able to provide the max compute at the lowest
Hmm.
power footprint. So overall, we are
Right.
able to get the highest power efficiency, energy efficiency, quotient chipsets, and keep the BOM and the design and everything
Yeah.
into a concised manner. So
Yeah, is there like you mentioned tops being sort of a hand wavy metric. I agree. Is there like more of a tops per watt, or what is the right way to think about AI horsepower per energy
yeah,
efficiency? Like is there a good metric out there yet?
again, I will again, instead of the tops per watt, my guidance would always be about performance per watt, right? So it's
Hmm.
inferences per second per watt. And if we can understand how much performance we are able to get out of given power
Hmm.
envelope, that helps a lot because that ends up
Yeah.
you telling that, hey, as we are going generation after generation, I should be able to give you more performance at the same power envelope. That's the
Sure,
metric
sure,
we
yeah.
want to
I
drive
like that.
towards.
Inferences per second per watt. Yeah. No, that's a good point, and I think more and more folks will start measuring solutions with those kind of metrics, which is great, and
Yep.
it's probably good for Qualcomm since you typically lead in that area.
Yes.
I had a quick question, maybe a sidebar. It was around Qualcomm Aware,
Hmm.
and that is a super low energy solution that I think also leverages not only LPWA and all these other cool IoT things, but probably some AI there
Hmm.
somewhere. And I mean, maybe you can kind of give our listeners some understanding of Qualcomm Aware and what you're trying to accomplish with that solution.
Yeah. So again, I mean, with Aware, what we have talked about are two major technologies, right? We have talked
Mm-hmm.
about location, we have talked about conditional monitoring. And when we talk about condition monitoring, it automatically goes and clicks into the land of AI as well. Because AI is
Mm-hmm.
not when we just think about a camera sensor or an audio sensor. AI comes into existence with thermal sensors, right? And
Mm-hmm.
imagine these fleet management systems where we are transferring goods, which could be in a very much thermal controlled environment. And that's where
Right.
we want to create alerts right now and there in a real time scenario if something drastic is going to happen, right?
Right.
And that's where we see AI coming into the play that, hey, now I have these thermal sensors which are continuously getting monitored. There is an AI of detection running on that thermal data to understand if something is
Mm-hmm.
going wrong and an equivalent alert coming up into the fleet management system.
Right. Right.
And I mean, again, there is a lot more we can think about from generative AI now coming into picture, right? On
Mm.
as you are traversing through in the same fleet management scenario and thinking about the best possible directions or the route guidance based on your conditions then and there. All right. So
Right. Right.
those are all those
Y-
different things where AI starts playing in and
Mm.
getting tightly looped into the aware services that we are providing.
Right, right. And the Aware, Qualcomm Aware is kind of a logistics, an end-to-end logistics kind of solution, like you said, for like monitoring thermal conditions or other. And this is where it's what's called anomaly detection. Sometimes they
Yes.
use that term too, which is like, there's a pattern, and then when they start seeing, breaks in that pattern,
Yeah.
then the AI can sort of give a heads up that, hey, there's something wrong is going on here, or there's some sort of, you know, condition that needs to be investigated. And I think that's a really interesting, kind of commercial implementation that combines a lot of the right technologies together, including AI. So yeah, no, I think it's fascinating, and I think there's a lot of kind of upside there as the silicon becomes more capable, more inferences per second per watt. Um, doing more edge processing of the environment and looking for those kind of changes in patterns
Hmm.
will be pretty powerful too, especially battery powered. I think
Yes.
when you get into sort of battery powered edge AI stuff, then it becomes pretty fascinating, and the use cases really start to expand. So it's great to hear about things like that. Let me talk a little bit about someone who spent a lot of time with edge AI myself. It's a lot of kind of leaders, a lot of commercial Fortune 50 execs love the idea. They think it's fantastic, and then they say go do it, and there's a struggle usually in some sort. And what are some of the things like that, like around tool chains and other areas that you think Qualcomm can do to help take the friction out of developing and deploying edge AI solutions?
Yeah. So, I mean, certainly software is a huge component of making AI successful. We talked about the hardware evolution. Yes, hardware evolution has catered to the requirements, but if the software cannot take care of or utilize that hardware
Right.
becomes useless at the end of the day. So, from a Qualcomm perspective, we certainly understand that. And, as a company where we used to think hardware first, we have marched into this whole direction of where we have to think about the two together, right? On how we will create hardware which would be leveraged by our software, or what other software components do we need to utilize this
Mm-hmm.
hardware
Mm-hmm.
uh, to be energy efficient, which is one of the most critical aspects that we discussed. We need to make sure that people are able, or our developers are able to use the embedded computing inside these cores, right? These are
Yeah.
not the regular and easy to use CPUs where you can just go and program in your floating point and get the things going, because that is not the most energy efficient way of doing things.
Hmm.
So you need to
Hmm.
know how to work into the integer math, and how to make the best use of the hardware. So for that, I mean, Qualcomm obviously, we have several patents around these things, and we have taken a step towards into the community, and we are going to do more and more, as you're going to see in the coming years, where we have launched certain tools like our AI model efficiency toolkit, where developers can go use these toolkits and design their
Hmm.
models when they are training their models at that very time itself. Bring it into these toolkits and prune them, optimize them, quantize them into an integer math, and make sure it is still something that they like and they are good with.
Right.
Once they are
Right.
able to do that, now they can move into the integer math. And now they can use our tools to do the actual inferencing and deployment side of things, which go hand in hand with our other toolkit on the training. So that's one
Right.
of the biggest things that are needed to make sure everything runs smoothly.
Hmm.
At the same time, the other bigger thing is having an ecosystem as well, right? Ecosystem of
Right.
software frameworks, ecosystem of developers who know this platform and who can preach and educate more about how to use these platforms. And that is another
Yeah.
space where, yes, Qualcomm has been investing a lot with different footprints, be it from DevOps or MLOps, or having application specific ISVs, third parties, to develop their applications
Yeah.
onto our chipsets.
Yeah, no, it's tricky. I mean, you're in the IoT space, so you know it's a very heterogeneous
Yeah.
space, right? And by definition, any solution is going to have a number of different kind of devices and sensors and gateways and things all connected, and they're probably from different vendors, and they probably have different silicon on them and all that other stuff. So, I mean, the nirvana is some sort of, cloud
Mhm.
native orchestration of workloads that goes from the cloud to the edge, and that everything's containerized and stuff. We're not there yet, but I think the same goes for ML ops, right? It's like, how do you talked about, for training in the cloud, and then how do you get that model optimized and on that piece of kit, that has a Qualcomm chip on it, and that model is optimized.
Mhm.
And I know there's companies like Modular AI and Edge Impulse and other folks trying to solve this problem. It's a computer science problem that's been around for decades. That's not just for AI, but it's sort of like, how do you, from a software perspective, as a software engineer, you always want everything to sort of look the same, so that you have the most, optionality in your endpoints. But obviously, from a semiconductor perspective, you want to be differentiated with your optimization, your designs, and so those two things sort of meet in the middle somehow. And I think that's kind of that's the Gordian knot that we need to figure
Yep.
out, is how to get these models to be, you know, uh, not seamlessly transportable, but at least somewhat more flexible in terms of, people are, let's say, really into CUDA and NVIDIA environments, and it's fantastic. And then
Mhm.
now they're on a project that runs this really cool Qualcomm based thing. Okay, so what's the short hop to get the NVIDIA developer now really up and an expert on the Qualcomm endpoints, and how do we do that? So I think that's it's good that you're focusing on that, because I think that's always going to be a bit of a challenge, but at some point it'll get smoother and smoother.
Certainly.
As,
And I think, like you
yeah,
said, right, there has to be a good marriage point between the differentiation and the ease of use and flexibility from these software frameworks. So
right,
we
right.
definitely understand. And that's why we are building and we are working through those ecosystems to make sure that people can, or developers can, seamlessly bring what they develop and
Right.
port onto our platforms
Yeah.
to the
Get up
seamless
and
degree
running.
we can. Yes.
Well, I kind of feel like the mobile folks at Qualcomm get this cool Hawaii event. What is the IoT? What's the next big thing for Qualcomm in the IoT space? Is it CES, or what's your next thing that you're looking forward to in terms of, events or news or whatever? What's the Snapdragon Summit equivalent for IoT coming up?
Yeah, so there are certainly tons of events that are planned through. I mean, some this year itself that you would come and see the
Hmm.
announcements coming out. For us in the IoT space, the proliferation, like I said, it's a very fragmented space. So there are different
Right.
events coming up from an industrial automation side of things. There is obviously a huge focus that will come into the NRF side of
That's true.
play.
Yeah,
That is
NRF
going to
is
be
in New
a big
York,
one
right? Is that New
because,
York in January, I
yeah,
think. Yeah.
and we started our discussion with retail, right? The transformation
Right.
in the digitalization and retail is just unbelievable. So that is going to be another big one. Obviously, we
Yeah,
talked a
there
lot
you go.
about developers. So you would see our bigger footprint in the embedded world, which is all around developers, and how,
Yeah.
from a Qualcomm IoT perspective, we are focused a lot towards those developers and how we are
Yes.
making end-to-end seamless for them. So those are some of
True.
them which are going to be upcoming. I'm sure I missed a few,
Cool.
but yeah.
By the way, I think we made history with this podcast. This is the first time I've heard a podcast with Qualcomm where we have not mentioned 5G. So
We are
congratulations. I
focused on
just said it there,
AI.
but you know, but so that, yeah, I guess that's a testament to how far Qualcomm's come in terms of the diversity of capabilities that are in the silicon these days. So, or 5G is not even a topic at this point, but we could do a whole other show on that.
No, 5G is
Um,
always there, right? It's all about intelligent computing. So
hmm
connected
hmm
intelligent computing.
Yes, of
Yeah,
course, by definition, it's almost inferred these days, but it's
yeah.
fascinating. Well, I really appreciate your time, Megha. I think, like I said, it's such a fascinating space and a challenging space, and it sounds like you spent a lot of your career trying to unpack some of these really difficult problems to solve, and it's great to see Qualcomm sort of pushing the envelope, and you have an AI on the edge sort of column blog thing going on that
Mhm.
people should look at. I think that's fascinating. Some pretty cool videos on YouTube that show some pretty cool demos. Any other kind of closing thoughts you want to leave us with?
It's just fascinating. Hopefully, the developers are enjoying this field as much as we are while developing it.
Right.
So there is a lot to come, and certainly look out for those more and more announcements from Qualcomm IoT
Awesome.
and AI at the edge.
Sounds good.
Yes.
Appreciate it, Megha. Thank you so much.
Thank you, Pete. It was a
Okay.
pleasure.
Thanks for joining us today on the Edge Celsior Show. Please subscribe and stay tuned for more, and check us out online about how you can scale your edge compute business.